In this video, we write a C program to find sum of digits of a given number using recursion. Now see here output. We have given a number 1, 2, 3, 4, 5, 6 and it is giving output value 21. How we got 21 value? 1 plus 2 plus 3 plus 4 plus 5 plus 6, and the entire value becomes 1 plus 2 3 plus 3 6 plus 4 10 plus 5 15 plus 6 21. This is the output we need to get. In this fashion, we need to write a C program to find out sum of digits of a given number using recursion. Here we have taken a function SOD. SOD is the shorthand form of sum of digits. It is taking a number, it is taking an integer argument, and it is returning sum of its digits. In the main function, we are reading n value. In the main function, we are reading n value, and then we are passing n value to SOD function, that is sum of digits function, and then value is assigned to sum, and then we are printing n value as well as sum value. Now observe here, this is the SOD function calling, sum of digits function calling. This is the code here, int SOD of integer n. Here the base condition is if n is equal to 0, then we are returning 0. This is the base condition code. Otherwise, we are performing recursive function calling. Otherwise, we are doing n mod 10 plus sum of digits of n by 10. This is the recursive code. The base condition is if n is equal to 0, we are returning 0. Otherwise, we are recursively calling sum of digits function with this logic. Now we see one by one. Now this is the code here. Now assume that we have taken a number 1, 2, 3. Now assume that n value is 1, 2, 3 in the main function, and then we are calling SOD of n. That means a copy of SOD function is created, and in this function n value is 1, 2, 3. That means here 1, 2, 3 is not is equal to 0, and then we come to else part. Here n mod 10. N mod 10 means we get remainder value. 123 mod 10, we get remainder value 3. 3 plus SOD of, again we are calling the same function, that is recursive function, SOD of n by 10. N by 10 means here n value is 123. 123 by 10 means we get value 12. We get quotient value, that is SOD of 12. SOD of 12. That means again we are calling the SOD function with the value we are passing 12. And another copy of SOD function is created. Now here n value becomes 12. Here also n is not is equal to 0, 12 is not is equal to 0. Again we come to else part. Here n mod 10, 12 mod 10 means we get remainder, that is 2 plus sum of digits of, again we are calling sum of digits function SOD of n by 10. 12 by 10 means we get quotient value 1. That means again we are calling SOD function by passing value 1. Another copy of SOD function is created. In this n value becomes 1. Here also n value is not is equal to 0. Again we come to else part. N mod 10. N mod 10 means we get remainder value 1. And SOD of, again we are calling recursive function SOD of n by 10. SOD of n by 10 means this value becomes plus SOD of n by 10. SOD of n by 10 means 1 by 10. The quotient value is 0. 0. Again we are calling SOD function by passing value 0. Another SOD function is created with n value 0. In this particular case, n value becomes 0. That means this particular condition is satisfied, and then we are returning 0. And then 0 is returned to its caller to this particular point. At this point of time, there will be no recursive function calls. That means now the recursion is stopped here. At this point of time, recursion is stopped, and 0 is returned to this particular place. And now this value becomes 1 plus SOD of 0. It has returned 0. 1 plus 0, 0. And this value is returned to this particular place. And this value becomes 2 plus here 1 plus 0, 1, and this value is returned to this particular place, 2 plus 1, and this value becomes 3, and this particular 3 is returned to this particular point. Here value becomes 3 plus, and the return value here is 3. 3 plus 3, 6, and this particular value is returned to this particular place. This is the point of calling. Now what is the value that gets here? That is 6, and this 6 is passed to sum, and finally we are printing n value. Now what is n value here? 123, and then we are printing sum value, and its sum of digits value is 6. In this fashion, this particular sum of digits recursive functions work. And now we see the stack involvement here. The stack involvement, initially the main function is called. Assume that we have given n value 1, 2, 3, 4. Then sum is equal to SOD of 1, 2, 3, 4 function is called. Sum of digits is called with n value 1, 2, 3, 4. Then a copy of sum of digits function is called with value 1, 2, 3, 4. Again it is calling SOD of 1, 2, 3. Another copy is created. Again this function is calling SOD of 12. Again SOD of 12 is calling SOD of 1. And SOD of 1 is calling SOD of 0. And finally SOD of 0 is returning 0. And now we see step by step here. Initially main function, let us say n value is 1, 2, 3, 4. And then it is calling SOD of 1, 2, 3, 4. That means a copy of the function is created with n value 1, 2, 3, 4. As n value is not is equal to 0, then we are performing n mod 10. 1, 2, 3, 4 mod 10 means 4 plus SOD of 1, 2, 3, 4 by 10. That will give 1, 2, 3. Then again SOD function is called with value 1, 2, 3. Here n value becomes 1, 2, 3. Again 1, 2, 3 is not is equal to 0. Then again we return n mod 10. 123 mod 10 means we get remainder 3 plus SOD of 123 by 10. We get a quotient value 12. Again SOD function is called with value 12. Another copy is created and its arguments are placed in the stack. Here n value becomes 12. Again 12 is not is equal to 0. Here n mod 10. 12 mod 10 means remainder 2 plus SOD of 12 by 10, that is quotient value 1. Again SOD function is called with value 1. Here n value becomes 1. And then again 1 is not is equal to 0. Then n mod 10. 1 mod 10 means we get remainder 1 plus SOD of n by 10. 1 by 10 means we get 0 quotient. Again SOD function is called with n value 0. Finally n value becomes 0. That means it returns a 0 value. This 0 value is returned to this particular point. And now this value becomes 1 plus 0. That is equal to 1. And this value is returned to this particular point. And now this value becomes 2 plus 1, 3. And this 3 is returned to this particular point. And here 3 plus 3 we get value 6. And this 6 is returned to this particular point. This value becomes 4 plus 6, 10. And this 10 is returned to the main function to this particular point, and this 10 is assigned to sum, and finally we are printing some value, that is 10. In this fashion, these recursive function calls will work. And once the functions are completed and the return value, then they are removed from the stack. In last in first out order. Then they are removed from the stack in this order. So first of all, SOD of 0 is lastly placed in the stack, then it is first removed, and then SOD of 1, and then SOD of 12, and then SOD of 123, and then SOD of 1, 2, 3, 4, and finally after printing some value, main function is also removed from the stack. In this fashion, recursive function calls will work.